Okay, these notes are about metric conversions. Now, the metric system is a system of measuring using factors of 10. And there are several base units, and it would be probably a good idea to know them. Like the base unit for mass is the gram. The base unit for length is the meter. The base unit for volume is the liter. The base unit for computer memory is bytes, which most of you should know by now. And the base unit for time is seconds. Okay, now when we want to go higher than the base unit or lower than the base unit, we add a prefix. Each prefix designates a power of 10, either larger or smaller than the base unit, which is considered 1. So if you look, we have tera, which is 10 to the 12, which kind of makes sense because a terabyte is a trillion bytes. Gigabyte, so giga is 10 to the 9th, so a gigabyte is a billion bytes. Mega is 10 to the 6th, which is about a million bytes from megabytes. And then you have kilo, which is 10 to the 3rd. And so most people, well, at least most computer people, know that there are 1,000 bytes of 1 kilobyte. Hecto, I don't even think there are hectobytes, but hecto is 10 to the 2 and deca is 10 to the 1. Now pay attention to the abbreviations, because when you write them in a problem, I am not going to write terabyte. I write T and the little b for the byte. We'll get into that when we get into some of the practice problems, but you have to know, the things that you have to know, especially on an exam, is this, that tera is T and that it's 10 to the 12th. So make sure you're writing these in your notes. You don't have to know the million part. Like this part you don't have to know. That's just kind of a showing you. I mean, we just did scientific notation, so you know 10 to the 12th is a trillion. But what you need to know is this right here. That is 10 to the 12th. Okay? And let's go down to the other ones. We've got the smaller ones. So deci is the little d. Now, if you notice, deca is DA. And that's because deci is little d. We couldn't use the little d for both because if I'm talking about DM, I need to know that it's decimeters, not decameters. So that's why they added the A. Some books you'll see it as a K because they used to spell it DEKA, and then they changed how they spelled it to DECA. So you may still see DK somewhere online, but right now it is considered DA. That is the generally known prefix. Then you have centi, which is 10 to the negative 2. Then you have milli, 10 to the negative 3. Micro, 10 to the negative 6. Nano, 10 to the negative 9. And pico, 10 to the negative 12. Once again, what I need you to know is that deci, oops, what am I doing? Sorry about that. Hang on, guys. Didn't mean to cross it out. I meant to highlight it. What you need to know is that deci is D, and it's 10 to the minus 1. So you're going to have to know these for the exam. Now, for the quiz, you're going to be able to use your notes. So I would still maybe write them down and practice them, just know them. Because on the exam, which that's probably another month or so from now, you're still going to have to know them. Okay, changing a measurement from one unit to another is called a unit conversion. In most metric conversions, we either multiply or divide, and I'm going to put in here, factors of 10 in here to get to the desired unit. So we're not going to multiply by 5 or multiply by 15. It's all they're going to be 10 or 100 or 1,000 or 0.1, 0.2, all of those numbers that you saw, like 10 to the negative 1, 10 to the 5th. Those are what we're going to be multiplying. So it's going to be factors of 10 to get to the desired unit. To make a base unit smaller, we'll divide by factors of 10. To make it larger, we're going to multiply by factor of 10. And we need to use a prefix to do that. Okay, so here's our first example. How many centimeters are in 1.3 decimeters? Now, we need to use dimensional analysis in order to do this because we're going to need to know whether we need to divide or multiply. And I'm going to require you to show me the work by doing dimensional analysis. But first, we've got to find our conversion factor. So we need to know how many centimeters are in 1 decimeter or how many decimeters are in 1 centimeter. So let's look at our little prefixes and they're the numbers. So DA, oh, hang on, this one. So DA, when you look on the front, is 10 to the 1. And C is 10 to the minus 2. So now centimeters is smaller than decimeters. That means there's going to be a lot more of the little units in one big unit. So we're going to say 1 decimeter or decameter equals, and now we're going to have to figure out how many centimeters. Now to do that, you're going to take the big number minus the smaller number, just the exponents. So 1 minus a minus 2 is a 3, is 10 to the 3 centimeters. Now, at this point in time, you can do one of two things. You can take 10 to the 3 and turn it into a regular number, if that's easier on your calculator, which some people like to do it that way. Some people like to just keep it as 10 to the 3. So, and 10 to the 3, if you remember, is 1,000. So we're going to say 1.3 decimeters. Now, I like to keep it the exponent, the power of 10. To me, that's easy. Rather than having, 10 to the 3 is 1,000. 10 to the 5 is what? 100,000. Trying to figure that out is really not fun. It's just easier to keep it 10 to the 3. Now, this is my conversion factor. So if you remember when we did dimensional analysis, we got to find the 1 and what's not the 1. So the 1 comes down here because we have 1 DAM. So that goes there, and then we have 10 to the 3 centimeters up top because the decimeter or decameters, can't talk today, cancel. So now 1.3 times 10 to the third, if you put that in your calculator, you get 1,300 centimeters. Now, at this point in time, I'm not too worried about sig figs because you should get the correct number of sig figs. Because if you remember, when we put into scientific notation, we put that in there in order to get rid of the non-significant digits. So, and if you didn't want to do this, you could also say the answer is 1.3 times 10 to the third centimeters. And that still works too, because that's what it is. Okay, for this one, we're going to turn how many kilograms are in 957 decigrams. Not deca, but deci. So really be careful with your prefixes. Oops. This one is the D. So your K is 10 to the 3. Your deci is 10 to the minus 1. So the K is bigger. So 1 kilogram equals, now 3 minus a minus 1, which is 4. 10 to the 4th decigram. So now we're going to start out with 957 decigrams. Okay, so this is our conversion factor. Decigrams goes on the bottom. And kilogram goes on the top. Okay, when you do the math, you're going to take 9, oops, shoot, why did it do that? 957 divided by 10 to the 4th, which comes out to be 0.0957 kilograms. Oh, okay, hang on a second. Let me move the number over because for some reason my margins on here are not doing very good. Okay, so 0.0957 kilograms. Now, if you want to put in scientific notation, you are more than welcome to. That would be 9.57 times 10 to the minus 2. I don't see the point because, I mean, you can. I think it's easier just to keep it the 0.0957. I guess if it was a huge number, you might want to, but on your calculator, if it's a huge number, we'll automatically put it into scientific notation, and you're allowed to report that number too. So either answer is correct. Okay, so this one is how many hectometers are in 257 millimeters. I want to change that because we just did one that was going the other way. So let's do this. Try to change this into milli and make this an H. So we're going to say how many millimeters are in 257 hectometers. Okay, so milli is, we're going to look that up, and that is what, 10 to the minus 3. And hecto is 10 to the 2. So 10 to the 2 is the bigger one. So 1 hectometer is, now we're going to take, we got to take the big, remember, it doesn't matter which one's first. You take the bigger number minus the smaller number. So 2 minus a minus 3 is 5. So it's 10 to the 5 millimeters. Okay. You can do it the other way if you want. You can do 1 millimeter is 10 to the negative 5 hectometers, but it's so much easier to do. Just remember, bigger one minus the smaller one, which means the bigger one is the one that gets the 1. Okay. Just know that there's 10 to the 5 difference. So if you really wanted to do minus 3 minus 2, you're going to get a negative 5, which means 1 millimeter equals, so 1 millimeter equals 10 to the minus 5 hectometers. You can use both of them. It doesn't matter which one you use. They're both exactly the same. There's a difference of 5, or of, what is that, 100,000, I think? There's a difference of 100,000 in there between the two. Okay, so 257 hectometers. And we're going to put 1 hectometer is 10 to the 5th millimeters. Now, I'm not going to use my calculator at the moment. If you don't use your calculator, you can get 257 times 10 to the 5 millimeters, which of course we have to put it into scientific notation. So if you remember those rules, if you move to the left, you add. So 2.57 times 10 to the 7th millimeters. Because if you do this in the calculator, it should give you, let me check my calculator, 257 times 10 to the 5th. It'll give you all of the numbers. It only gives you the exponents when you get past 9, I think it is. Most of them when you get past 9. So it's going to give you the 2, 5, 7, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There we go. There we go. Number. So it's up to you. I mean, whichever the way is easiest. This one needs to be converted. So this one has to go down to here. So these two here, this one and this one, are correct answers. Okay, let's look at this one. How many grams are in 0.35 centigrams? So gram is your base unit. So grams is 10 to the 0. All of your base units are 10 to the 0. Which is 1, because it's the base unit. It's where you start. It's the bottom. So 10 to the 0. Just think of the 10 to the 1, 10 to the negative 1. Those are floors. Go up 1 floor is 10 to the 1. Go up a second floor is 10 to the 2. Go down a floor is 10 to the negative 1. Go down 2 floors is negative 2. Whereas 10 to the 0 is your ground floor. So the littler ones are in the basement. The bigger ones are the stories above it. So grams is 10 to the 0. Centi is 10 to the minus 2. So 1 gram equals, so we're going to take 0 minus a minus 2. So we get 2 is, or 100, if you want to put it out in regular numbers and you don't want to keep it in scientific notation. As I said, I like the exponents because to me it's 10 times easier because I don't have to convert anything else. It's 10 to the 2 as far as I'm concerned until you get later on. So we got 0.35 centigrams. We're going to put 10 to the 2 centigrams down here. 1 gram. Centigrams cancel. And then when we do that, we get 0.035 grams. Or 3.5 times 10 to the 1 to negative 3 grams. Either one does, it doesn't matter. Sometimes it's easier. If it's a small enough number, just keep it that way, or you can put it in the scientific notation. It's up to you. I don't really care. Both answers are correct. Okay, so we're going to try another example, one that I didn't have already pre-prepared on my slides. So we'll call this example 5. If I can get my pen working. Example 5. Now we're going to do some computer related, because most of you guys know about kilobytes, megabytes, gigabytes, and terabytes. So I want to know how many megabytes are in 1.8 gigabytes. Drive, or a 2 gigabyte drive, and I have 1.8 gigabytes left, but I need to know how many megabytes that is, because all of my files are in megabytes and I got to add up all my megabytes. So to do that, so giga is 10 to the 9th, mega is 10 to the 6th. So 1 in 1 gigabyte, there are 9 minus 6, which is 3. 3, actually, sorry, that's 10 to the 3. Ten to the 3 gigabytes. And we're going to put 1 gigabyte on bottom, 10 to the 3 megabytes on top. And we get 1.8 times 10 to the 3 megabytes. Or if you're trying to actually add them all up, that's 1,800 megabytes. So see how this actually can be useful. And then terabytes. If I have a terabyte drive, how many megabytes, if my files are all megabytes, how many files can I fit on a 2 terabyte drive? So you just add them all up. So, I mean, you can kind of use that. Let's say I have a terabyte drive and I've only got, well, let's say I've got a 2 terabyte drive and I've only got maybe 1.6 terabytes left because I use 0.4 terabytes. So then you can figure that out. So there are useful things with unit conversions and metric in our everyday lives. Okay, well, that's it for tonight. And we'll do some practice problems tomorrow. See you later. Bye.